Hey everyone, welcome back to Code Happy 101. Today we're diving into a fantastic topic, designing a unique ID generator in distributed systems. This is a critical challenge in system design, especially for large-scale applications. So let's get started. An example of an ID is just a monotonically increasing number as shown here. You can see the first couple digits are the same except for the last one, it's increasing. So we want to design a system that can generate these IDs in a distributed system. So the first step in tackling a system design problem in an interview is to understand the requirements and the scope. Let's go through some essential questions you should ask. What are the characteristics of a unique ID? How should IDs increment? Are IDs numerical values only? What is the ID length requirement? What scale is the system? For this particular problem, here's what we know. The IDs must be unique and numerical. They should fit into 64 bits. IDs need to be ordered by date and supporting generating over 10,000 unique IDs per second. Now let's explore some high-level options to generating unique IDs in distributed systems. Here's a few potential solutions. We can use UUIDs, which are universally unique identifiers. We can use a single server that can be generating unique auto-incrementing IDs. Or we can use Twitter's Snowflake approach. Let's briefly discuss each one. A UUID is a 128-bit number used to uniquely identify information in computer systems. UUIDs are widely used in software development to ensure objects within a system can be referenced uniquely without a central authority to coordinate assigning these identifiers. The characteristics are that it's unique, it's independent, and there's a standard format, as you can see here. There are different versions, V1, V2, V3, V4, V5, that have different characteristics. Its use cases are database keys. It can be used as primary keys in databases. You can use them as file identifiers. In distributed systems, you can use them to ensure uniqueness across different nodes. They can be used as transaction IDs. However, the cons for UIDs that are that it's 128 bits. It lacks ordering. The standard UIDs are not inherently ordered. It's complex. The second option is having a single server, a centralized server that can generate unique IDs that could be backed by, say, a database that is auto-incrementing the ID. It's easy to implement and provides a numeric ID. However, it's a single point of failure. We can have multiple ticket servers, but this introduces synchronization challenges. And the final approach is using a Snowflake, which divides the ID into different sections: a signed bit, a timestamp, a data center ID, a machine ID, and sequence number. This fits our approach requirement perfectly. Let's dive deeper into this design. The Snowflake approach uses a 64-bit ID structure. The signed bit, which is always 0, that keeps the ID positive. The timestamp which is 41 bits, represent the number of milliseconds that have elapsed since a custom epoch. This ensures the IDs are time ordered. The data center ID is 5 bits, which identifies the data center which the ID was generated, and allows up to 32 data centers. The machine ID is 5 bits, and it identifies the machine within the data center the identifier was created. And this allows up to 32 machines per data center. The sequence number is 12 bits, which is a counter that is incremented for every ID generated within the same millisecond. This allows for up to 4,096 unique IDs per millisecond per machine. The key features of a Snowflake ID is that it's time ordered, it's distributed, it's scalable, it's globally unique. However, the cons are that it's complex compared to simpler ID generation strategies and relies on clocks to be synchronized across distributed systems. Snowflake IDs are efficient and can serve as a scalable solution for generating unique IDs. And in this case, we'll go with this approach. Let's take a look at an example. If we have the following Snowflake ID, we first generate the binary version. The first bit is 0, that's the signed bit. The following 41 bits is the timestamp, and in this case, it's in milliseconds since the epoch December 16th, 2020, representing that date. The data center ID is 0, machine ID is 0, and the sequence number is 0, which is the first ID generated in that milliseconds. Next, we can move into our system design. We'll have a dispatch service that will take in the request and dispatch it to our Snowflake ID services. The Snowflake ID services will generate the ID and then return that ID back to the dispatch service, which will then return back to the client. We've discussed various approaches in generating unique IDs in distributed system. We chose the Twitter Snowflake approach because it meets our requirements and scales well in distributed environments. Remember, there are additional considerations like clock synchronization and high availability that we haven't covered in detail. If you have extra time, these are excellent points to dive into. Congratulations on making it this far. Designing a unique ID generator is a complex but rewarding challenge. If you found this video helpful, give it a thumbs up, share it with your friends, and subscribe for more system design tutorials. Thank you for watching.